Hi, we are Team E6 and this is our automated watering system prototype. As many of you know, the recent COVID-19 pandemic has faced society with a number of challenges. Our design was initially inspired by these challenges, and specifically the challenges of going to the store and food scarcity. The purpose of our design is to provide a means of growing food for people with limited space and time, including college students, the elderly, and people living in urban areas. Many of us on the team have experienced plants falling into neglect, so we wanted to create an automated system that allows for a hands-off approach to growing your own food. With space being a limiting factor for our target users, we identified a need for a compact, versatile design with a small footprint.
Our main goal with our system is to grow herbs and vegetables in an indoor space with little to no natural resources. We were also hoping to achieve an aesthetically pleasing product that was affordable and space efficient. Overall, we achieved our main goal of an automated plant growth while also keeping our minor goals in mind. Our automated watering system, along with our potting grid, allows for efficient plant growth with little interaction. Space efficiency was achieved by placing the baskets and water tank systematically to work with our watering system without it looking like a mess. The pegboard allowed us this flexibility to place them in a grid-like pattern on the board. We achieved affordability by using more common items instead of specific high-end products and made those products fit our needs instead of finding more expensive products made for our purposes. Aesthetics were kept in mind while choosing the product's components and keeping a color theme to make the product look more like a solid unit.
The main subsystems of our design include the electronics, pump, plant holders, and hanging structure. During initial prototyping for the electrical system, it was deemed unnecessary to include a piezo speaker.
Through our initial prototyping of the pump system, we were able to choose a pump that was optimal for our design. We also discovered the challenges associated with having hose outlets at different elevations that we would need to overcome later.
Through the initial prototyping of the plant holding subsystem, it was determined that water would be delivered directly on top of the soil and that a permeable material, such as burlap, should be used to prevent root rot.
Once our team had conducted their individual prototyping and testing, we began the system integration step. This started by setting up the electronics on the pegboard and laying out the wiring to ensure that it would be of sufficient length. Next, we added the pump and tubing and tested water flow rate. After testing the electronics and water system, we added baskets and plants to conduct further tests. Our biggest concerns with this design were the board falling off the wall due to weight and water leaks causing property damage. The first issue was resolved by using drywall mounting screws, which increased the support. The potential water issue was resolved by checking every step of the water system and ensuring the reservoir and connections were all watertight.
To start putting together our overall prototype, we assigned different tasks to members using Smartsheet. We then could also see the timeline we had to complete our tasks. Items were purchased individually and recorded on Miro, and then they were paid back at the end of the project. Once our individual subsystems were completed, we put the subsystems together over 2 weekends to come up with our final prototype.
One problem that required multiple attempts to get right was getting the water distribution equal between all 4 plant boxes. This was fixed by limiting the diameter of the tubes that flowed to the bottom boxes. A final prototype would improve this even more by using a differently shaped splitter that promotes even water distribution. With more resources, this prototype will become a marketable product. Improvements to multiple components can be made by manufacturing them specifically or sourcing more ideal parts. The baskets that hold the plants could be resized to hold more soil, as well as the water tank to hold more water closer to the wall, reducing its strain on the board. With an additional month of prototyping, more detail could be paid to the electronics side. Streamlining the hardware by using an Arduino that only has the features we need would reduce costs. Taking a closer look at the software and honing in the parameters of when and how much to pump could increase efficiency and decrease energy usage. Another area that would be improved upon on the next prototype would be water delivery to the plants. Currently, each box gets water, but only from one location. As a build-it-yourself product, packaging and instructions will also need to be addressed. Thank you for taking the time to watch our presentation. Consider investing in our team for your wall herb needs.